What if the stars weren't just pretty lights? What if they were a clock, a map, and a god all at once? For us, looking up at the night sky is a hobby. For ancient people, it was survival. It was everything. They saw patterns we miss. They tracked cycles we ignore. Entire civilizations around the movements of the sun, moon, and stars. Some of them knew things about the cosmos that we thought were only discovered with modern telescopes. They predicted eclipses to the day. They aligned massive stone structures to planetary cycles with laser precision. They created calendars more accurate than the one we used just a few centuries ago. How did they do it? Without computers, without advanced optics, how did they map the heavens so perfectly? And what else did they know that we've now forgotten? Number 20. How did an empire's faith shape its view of the stars? The ancient Persians saw the universe as a battlefield. It was a cosmic war between light and darkness, between truth and lies. This wasn't just a metaphor. It was the core of their religion, Zoroastrianism. And this belief shaped everything they did, including how they looked at the sky. The stars were not neutral. The planets were not just wandering rocks. They were soldiers in this great conflict. The sun and the moon were forces of Ahura Mazda, the god of light and wisdom. Eclipses, comets, and meteors were seen as omens, messages from the front lines of the cosmic war. Their calendar was deeply tied to this belief. The new year, Nowruz, wasn't just on a random day. It was fixed to the vernal equinox, the moment light begins to win its battle over darkness, when days become longer than nights. This wasn't a casual observation. It required careful, year-on-year, tracking of the sun's position against the background stars. Another major festival, Yalda Night, celebrated the winter solstice. This was the longest night of the year, the moment of darkness's greatest triumph. People would stay up all night, keeping fires lit to help the sun be reborn the next morning. It was a ritual of cosmic support. This religious focus on celestial events meant they needed good astronomers. The Magi, the priestly class of ancient Persia, were renowned for their knowledge of the stars. The word magic actually comes from their name, but it wasn't magic in our sense. It was a science of observation and interpretation. They created some of the first star charts. They were aware of the precession of the equinoxes, that slow wobble of the Earth's axis that changes which star is the North Star over thousands of years. This is a subtle, long-term observation that many other cultures missed. The Greek astronomer Hipparchus is often credited with discovering precession around 130 BC, but many scholars, like the Belgian astronomer Franz Cumont, argued he likely inherited this knowledge from Babylonian or Persian sources. The Achaemenid Empire, founded by Cyrus the Great around 550 BC, standardized a 365-day calendar based on Egyptian models but infused with Zoroastrian meaning. It had 12 months of 30 days each, plus 5 extra days at the end. They understood a year was slightly longer than 365 days, and they dealt with this problem, though their methods for intercalation, or adding leap days, are still debated by historians. Their knowledge was so respected that when the later Islamic Golden Age began, much of its astronomical foundation was built upon Sasanian Persian texts and observatories. Its figures, like Al-Khwarizmi, the father of algebra, worked from Persian and Indian astronomical tables. The famous observatory at Moraga, built in the 13th century, was a direct descendant of this ancient Persian focus on the stars. But so much is lost. The burning of the library at Persepolis by Alexander the Great in 330 BC was a catastrophe for historical records. We have to piece together their knowledge from Greek accounts, later Persian texts, and archaeological clues. We know they were brilliant. We know their view of the cosmos was deeply intertwined with their morality. They weren't just watching rocks and gas, they were watching a divine story unfold, a story they were a part of. What we still don't know is terrifying. What specific astronomical records were lost in the fires of Persepolis? Did they have a theory of planetary motion that predated the Greeks? And if they saw the cosmos as a moral battle, did they ever conceive of a universe that was simply indifferent? And what would that have done to their entire civilization? Number 19, could a society carve its star maps into the earth? In the river valleys of southern Ohio, an ancient people left behind a mystery. They didn't build in stone, they built with earth. Between 100 BC and 500 AD, the people of the Hopewell tradition created enormous geometric earthworks. There are circles, squares, and octagons spread across hundreds of acres. For a long time, people thought they were just forts or ceremonial grounds. But they are something far more complex. They are a map of the heavens, built on a colossal scale. The Newark earthworks in Ohio is one of the most incredible examples. It includes a massive circle connected to an even bigger octagon. Researchers William F. Romaine and Ray Hively have spent decades studying these sites. In a series of papers starting in the 1980s, they show that the octagon is a precise lunar observatory. Its main axis aligns with the northernmost rising of the moon. This isn't a simple event like the solstice. The moon's rising and setting points move along the horizon in a complex cycle that takes 18.6 years to complete. The Hopewell people tracked this cycle. They knew its extreme points, the northernmost and southernmost moon rises, and they embedded that knowledge into the very ground they walked on. The parallel walls of the octagon's entranceway frame this event perfectly. It's not a coincidence. The odds of it happening by chance are, pardon the pun, astronomical. This wasn't just for show. Understanding the lunar cycle was critical. It helped them regulate a calendar that could reconcile the solar year with the lunar months. For a society that relied on agriculture and seasonal rituals, this was advanced timekeeping. It meant they could predict seasons and organize their society with a precision we barely appreciate. They were doing this 1,000 years before similar geometric knowledge re-emerged in European cathedrals. Another site, the Great Serpent Mound, also in Ohio, seems to be aligned with the sun. The serpent's head points toward the sunset on the summer solstice. Some researchers, like Dr. John Carlson, a specialist in archaeoastronomy, have also suggested it might mark the passage of Halley's Comet in 1066 AD, though this is a more recent theory and highly debated. What is clear is that the builders were master surveyors and observers of the sky. To lay out these perfect geometric shapes over such vast distances required a sophisticated understanding of measurement and geometry, something akin to a Hopewellian Pythagorean theorem. The problem is, the Hopewell people left no written language. All we have are these silent, grassy mounds and the artifacts buried within them. We have no texts explaining their cosmology, we have no star charts on papyrus. Their book was the earth itself, their language was geometry. We are left to reverse engineer their knowledge from the angles of their embankments and the orientation of their gateways. It's like trying to understand a computer by looking at the motherboard without knowing what electricity is. So what are the big unanswered questions? How did a pre-literate society transmit such complex geometric and astronomical knowledge across generations? Was there a special class of astronomer priests who directed this monumental construction? And if they were mapping the moon's 18.6-year cycle, what other long-term cycles did they observe that we haven't even thought to look for in their earthworks yet? Number 18, can a village be a reflection of the night sky? For most cultures, the stars are up there, and we are down here. There is a separation. But for the Skidi Pawnee of North America, that separation didn't really exist. Their villages, their rituals, and their entire social structure were a mirror of the stars. They didn't just observe the sky, they lived inside their star map. The Skidi homeland was in what is now Nebraska. Their connection to the cosmos was one of the most direct and profound of any culture on Earth. Their cosmology was centered on Tirawa, the supreme creator who had arranged the stars in the sky. Certain stars were given special powers and duties. Morning star and evening star were particularly important deities. The Pawnee believed their world was created when morning star Mars pursued and captured evening star Venus. Their union created the first human being. This wasn't just a story told around a fire. It was the organizing principle of their society. Pawnee villages were laid out to reflect the positions of key stars. The ethnographer James Murray, himself of Pawnee descent, worked with anthropologist Clark Whistler in the early 20th century to document these traditions. They recorded how different villages represented different star clusters. The pattern of villages along the Loup River in Nebraska mirrored the pattern of stars in the Milky Way. Each village had a central fireplace that corresponded to a specific star, and the positions of the lodges within the village reflected the positions of other stars in a constellation. Their homes, the Earth lodges, were also microcosms of the universe. The dome-shaped roof was the sky. The four central posts that held up the roof represented the four semi-cardinal stars that held up the heavens. The smoke hole at the top was the zenith, the direct path to the spirit world above. Their rituals were timed by the stars. The most dramatic was the morning star ceremony. This ritual, which involved a human sacrifice, has been sensationalized, but its astronomical roots are undeniable. It was performed only when morning star appeared in a specific way as a harbinger of the dawn. It was meant to be a reenactment of the creation story, a way to rejuvenate the earth and ensure the fertility of the crops. It was timed with incredible precision. The astronomer von Del Chamberlain wrote extensively about Pawnee astronomy, showing how their understanding was both deeply spiritual and scientifically accurate. They used a star chart, a rawhide map of the heavens to teach the next generation and to keep track of their complex cosmic clock. This wasn't just about big events. They used the constellations Ursa Major and Ursa Minor to tell time at night. They knew the solstices and equinoxes. Their entire life was a performance of the celestial drama. When they looked up, they didn't just see stars, they saw their family, their history, and their destiny. The questions that remain are haunting. How much of this intricate knowledge was lost during their forced relocation to Oklahoma in the 1870s? Were their star charts more detailed than the few surviving examples suggest? And if their entire society was a mirror of the cosmos, what happened to their sense of self when they could no longer build their villages in the sacred patterns their ancestors had followed for centuries? Number 17. What secrets does a sunken city hold about the stars? Off the coast of southern Peru, there is a place where the desert meets the sea. Here, another culture flourished long before the Inca. They were the Moche. Between 100 and 700 AD, they built huge pyramids of mud brick, called huacas, and created some of the most stunningly realistic pottery in the ancient world. They had no writing system that we've deciphered, but they left behind a rich visual language in their art, a language filled with gods, demons, and stars. The Moche were obsessed with cycles, the cycle of life and death, of seasons, of the sun and moon. Their entire cosmology seems to have been built around the idea of cosmic duality and renewal, and the sky was the ultimate source of these cycles. One of their chief deities was a figure scholars call the decapitator god, often depicted as a spider or a fanged creature holding a severed head and a ceremonial knife. This sounds brutal, but it was likely tied to agricultural fertility and celestial events. Human sacrifice was a key part of their ritual life, and these rituals were almost certainly timed by astronomical observations. Archaeologists have found compelling evidence of this at sites like the Huaca de la Luna, the Pyramid of the Moon. This was not a tomb, but a place of ritual. Excavations led by scholars like Steve Bourget have uncovered evidence of mass sacrifices that coincided with major El Niño events. In El Niño, the periodic warming of the Pacific Ocean brings catastrophic flooding and disrupts the entire ecosystem. So for the Moche, this would have been a cosmic crisis. It's likely they looked to the sky for answers and for a way to appease the angry gods. They would attract the Pleiades star cluster, which was a key agricultural indicator throughout the Andes. The visibility of the Pleiades just before dawn in June signaled the time for planting. If the stars appeared dim, it was an omen of a bad year, possibly linked to the atmospheric haze caused by El Niño conditions. Their pottery also gives us clues. We see depictions of figures with star-like rays emanating from their heads. We see scenes of celestial battles. Some scholars, like Elizabeth Benson, have interpreted certain recurring symbols as representations of constellations or planets. The Moche likely had a complex zodiac, but without a written key, we are left to interpret the pictures. It's a cosmic puzzle. The Lord of Sapon, whose undisturbed tomb was discovered in 1987 by Walter Alva, was buried with incredible wealth and artifacts that point to his role as a divine ruler connected to the heavens. His regalia included items that represented the sun and the moon. He was the earthly intermediary, the one who could interpret the will of the celestial gods and guide his people. His power came from his mastery of this cosmic knowledge. The Moche civilization collapsed around 800 AD, likely due to a combination of extreme weather, a super El Niño followed by a long drought. Their world was torn apart by the very cosmic forces they tried so hard to understand and control. But what don't we know? Without a written language, can we ever truly understand their names for the constellations or their myths about the planets? Were their pyramids, the huacas, aligned to celestial events that we haven't yet identified? And when their world was ending, when the rains and drought came, did they believe the stars had finally abandoned them? Or did their astronomical observations predict the catastrophe to come? Number 16 was a city of stone, a giant astronomical device. Imagine carving a city out of solid rock. Not building it, but carving it. That's what the Nabateans did at Petra in modern-day Jordan. Between 400 BC and 106 AD, this trading kingdom created a masterpiece of engineering and art. We think of Petra for its famous treasury, the building front from Indiana Jones. But the entire city is an astronomical instrument designed to track the sun and sanctify its power. The Nabateans were masterful engineers, but they were also sun worshippers. Their main god was Dushara, who was associated with the sun. Their architecture reflects this obsession. The entrance to the City of the Sick is a long, narrow canyon. As you walk through it, the treasury is slowly revealed. On the winter solstice, something amazing happens. As the sun sets, its light funnels through the Sick and illuminates the facade of the treasury, but not the whole thing. It lights up the central figure on the upper level, a goddess believed to be Alyuza, an aspect of the evening star Venus. It's a piece of celestial theater. This isn't the only alignment. The monastery, another massive structure carved high in the hills, has an entrance that is perfectly aligned to the setting sun on the winter solstice. On that day, the light enters the main chamber and illuminates the sacred block, or motab, at the back. It's a deliberate design meant to mark a sacred time of year. Juan Antonio Belmonte, a leading researcher in archaeoastronomy, has studied Petra extensively. He and his team have shown that many of the most important structures in the city are aligned with the solstices, equinoxes, and other key solar positions. The Great Temple of Petra has a processional way that seems to be oriented to the rising sun at the winter solstice. The main cultic areas were designed to create dramatic light and shadow effects on these important solar dates. It was a way of making the calendar sacred. It told people when to plant, when to celebrate, and when the gods were closest to them. For a trading culture that had to manage caravans crossing vast deserts, a precise calendar was essential for survival and commerce. Since they didn't just track the sun, the Nabateans also incorporated lunar and stellar alignments. Some tombs and temples seem to be oriented toward the rising of certain bright stars, like Sirius. They blended their own Arab traditions with Hellenistic and Roman influences, creating a unique astronomical synthesis. Their ability to survey and carve with such precision in solid rock is mind-boggling. They were using simple tools, A-plumb lines, square levels, and observation to achieve results that would be challenging even with modern technology. But the Nabateans were absorbed by the Roman Empire in 106 AD. Over time, their unique culture and language faded. We have very few of their own writings. Most of what we know comes from Roman historians or from the silent testimony of their rock-hewn city. So the questions remain. What other astronomical alignments exist at Petra that we haven't found yet? Did they have a more complex understanding of planetary motion, similar to the Babylonians from whom they inherited some traditions? And what happened to their detailed astronomical records? Are they buried somewhere beneath the sands waiting to be discovered, or were they lost forever when their culture was assimilated by Rome? Number 15, did the first cities rise from the first star charts? Before the Egyptians, before the Greeks, there were the Sumerians. In the Fertile Crescent between the Tigris and Euphrates rivers in what is now Iraq, they built the world's first cities around 4,500 BC. They invented writing, the wheel, and the 60-second minute. And they may have been the world's first true astronomers. For the Sumerians, the sky was not a mystery to be solved. It was a divine text to be read. They believed that the gods lived in the heavens and that the movements of the planets were the gods communicating their will to humanity. The sun god Utu and the moon god Nana were two of the most important deities in their pantheon. The planet Venus, which they identified with the goddess Inanna, was particularly important. They tracked its movements with obsessive accuracy. They knew it appeared as both a morning star and an evening star, and they understood its cycle. This wasn't just religion, it was intensely practical. The Sumerians were farmers. They needed to know when to plant and when to harvest. The sky was their calendar. They divided the year into two seasons, summer and winter, and marked them with the cycles of the sun and moon. They developed a lunisolar calendar, trying to reconcile the 29.5-day lunar month with the 365.25-day solar year. To do this, they occasionally had to add an extra month to their year, a practice known as intercalation. Deciding when to add this month required careful and continuous observation. Their greatest contribution to astronomy and to all of history was their number system. They used a sexagesimal system based on the number 60. We still use it today. A minute has 60 seconds. An hour has 60 minutes. A circle has 360 degrees. Why 60? It's a highly composite number, divisible by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. This made calculations with fractions incredibly easy, which is essential for tracking astronomical cycles. They divided the celestial sphere into 360 degrees, and they likely created the first zodiac, dividing the sun's path into 12 equal parts, each marked by a constellation. The names we use for many constellations, like Leo the Lion and Taurus the Bull, are direct translations of the Sumerian names. They built ziggurats, massive step pyramids that served as temples. These were not just places of worship. They were observatories. From their high, flat tops, priests would track the movements of the stars and planets, recording their observations on clay tablets in cuneiform script. The thousands of these tablets have survived. They are the oldest astronomical records in the world. The science historian Otto Neugebauer spent his life deciphering these texts, revealing the mathematical sophistication of these early astronomers. The Sumerians laid the foundation for everything that followed. The Babylonians, the Assyrians, the Greeks, they all built upon Sumerian knowledge. The very idea that the universe could be understood through mathematics and observation started here, in the mud brick cities of ancient Mesopotamia. And yet, there are huge gaps in our knowledge. How did they first develop the sexagesimal system? Was it a sudden invention or a slow evolution? Did they have a model of the solar system, even a rudimentary one, that went beyond simple observation? And what did they believe existed beyond the stars they could see? Was their universe infinite, or did it have an edge? Number 14, who were the people who taught the Maya about time. Long before the great Maya cities of Tikal and Chichen Itza rose from the jungle, another civilization laid the groundwork. They were the Olmec, the rubber people, who flourished in the lowlands of south-central Mexico from about 1500 BC to 400 BC. They are famous for their colossal stone heads, massive sculptures of rulers that weigh up to 40 tons. But their most enduring legacy might be time itself. The Olmec were the likely inventors of the complex calendar systems that would define Mesoamerican culture for the next 3,000 years. The Olmec were keen observers of the sky. Their world was oriented by the sun's path. Major Olmec centers like La Venta were built on a north-south axis, but with a slight deviation of 8 degrees west of north. Why? For a long time, it was a mystery. But archaeoastronomers like Marion Popeno Hatch have suggested this alignment points to the rising sun on key dates, possibly marking the beginning of the planting season. The entire layout of their sacred cities was a form of solar calendar. Their greatest innovation was likely the creation of the 260-day sacred calendar, or Tzolk'in, as the Maya would later call it. This calendar, with its interlocking cycle of 13 numbers and 20-day names, is unique in the world. Its origin is debated. Some scholars, like Vincent Malmstrom, proposed it relates to the time between the sun's zenith passages at the latitude of early Olmec sites. The sun passes directly overhead twice a year in the tropics, and the gap between these passages is around 260 days. It was a calendar perfectly suited to their geography. This 260-day cycle was combined with a 365-day solar year to create the 52-year calendar round, a system that would be used by nearly every subsequent Mesoamerican culture. The Olmec may also have been the originators of the long count, the famous calendar that tracks time from a mythical starting date in 3114 BC, and which caused so much fuss about the year 2012. The earliest long count date yet found is on Stela II at Chiapa de Corzo, a site with strong Olmec influence, and it corresponds to the year 36 BC. This suggests the system was developed either in the late Olmec period or by their immediate cultural heirs. This required a sophisticated understanding of mathematics, including the concept of zero, which they represented with a shell symbol. The invention of zero was a massive intellectual leap, one that European mathematicians wouldn't make for another 1,000 years. We see their astronomical focus in their art. The famous Olmec, where jaguar motif, a hybrid of a human and a jaguar, might represent a constellation or a cosmic force. Their ceremonial axes and celts are often inscribed with symbols that could be astronomical. But without a deciphered script, we are guessing. We are trying to read a story where most of the pages are missing. They were the mother culture of Mesoamerica, but they are a mother we barely know. So what are the big unknowns? Can we ever be certain they invented the long count, or did they inherit it from an even earlier undiscovered culture? What was their zodiac like? Did they have names for the planets, and did they track their movements against the stars? And what cosmic event, if any, did they believe happened on the zero date of their great calendar in 3114 BC? Number 13, did a West African tribe know about an invisible star? This is one of the most controversial and fascinating stories in the history of astronomy. It centers on the Dogon people of Mali in West Africa. In the 1930s and 40s, two French ethnographers, Marcel Griol and Germain Dieterlen, spent years living with the Dogon. After being initiated into their deepest tribal secrets, they published papers that shocked the world. They claimed the Dogon possessed extraordinary astronomical knowledge that they had no right to have. The core of the claim revolves around the star Sirius, the brightest star in our sky. The Dogon, according to Griol, knew that Sirius was not a single star. They knew it had a tiny, invisible companion star. They called this companion Po Tolo. Tolo means star, and Po is the name of a tiny, important seed. They said this companion star was incredibly heavy, and that it moved in an elliptical orbit around Sirius every 50 years. Here's the stunning part. All of this is true. Sirius does have a companion star. It's called Sirius B. It's a white dwarf star, invisible to the naked eye. It is incredibly dense and heavy, and its orbital period is 50.4 years. Sirius B was only discovered by Western astronomers in 1862, and it wasn't even photographed until 1970. The fact that it was a super dense white dwarf wasn't understood until the 1920s. So how could the Dogon have known this for centuries? Griol and Dieterlen claimed this was ancient, secret knowledge passed down through generations. The story became a sensation, especially for ancient astronaut theorists who proposed the Dogon must have been visited by extraterrestrials who gave them this knowledge. The evidence seemed compelling. The Dogon had drawings that appeared to show the elliptical orbit. Their rituals, like the Sigi ceremony, were held every 50 years to match the orbital period of Potolo. But there's another side to the story. Skeptics, most famously the astronomer Carl Sagan, began to question the claims. Sagan suggested that Dogon knowledge could have come from cultural contamination. A Western visitor, a missionary or a soldier, who knew about the recent discoveries about Sirius B, could have visited the Dogon sometime in the early 20th century. The Dogon, being an intellectually curious people, might have incorporated this new information into their own existing mythology. Later, when Griol arrived, they presented this syncretic myth as ancient wisdom. More damning evidence came from an anthropologist named Walter van Beek. In the 1990s, he spent over a decade living with the Dogon and specifically tried to verify Griol's claims. He found no trace of this deep astronomical knowledge. The elders he spoke to knew about Sirius as a single star, but they knew nothing of Sirius B, its 50-year orbit, or its incredible density. Van Beek concluded that Griol had likely misunderstood or overinterpreted the information he was given, perhaps unintentionally leading his informants to give him the answers he wanted to hear. So we are left with a deep puzzle. Was it a case of genuine ancient knowledge, alien contact, cultural contamination, or flawed ethnographic research? The debate still rages. The shocking questions are obvious. If Griol was right, how is it possible they knew? If he was wrong, how could a respected academic get it so fantastically wrong and create such a specific, detailed, and accidentally correct myth? And if it was contamination, who was the mysterious visitor who told the Dogon about a white dwarf star in the 1920s, and why has no record of this exchange ever been found? Or number 12, how did people build a perfect clock with a dagger of light? In the remote Chaco Canyon in New Mexico, a mystery sits atop a high butte. Discovered by accident in 1977 by an artist named Anna Sofire. She was documenting petroglyphs, ancient rock carvings, when she noticed something strange. 3 large stone slabs were leaning against the rock face. Behind them, carved into the rock, was a large spiral. As the sun shone through the gaps in the slabs, a thin sliver of light moved across the spiral. She realized she had stumbled upon a celestial calendar. She called it the Sun Dagger. This was the work of the ancestral Pueblones, sometimes called the Anasazi, who inhabited this region from about 850 to 1250 AD. On the summer solstice, the longest day of the year, a single dagger of light appears near the top of the spiral and cuts right through its center. On the winter solstice, the shortest day of the year, 2 daggers of light appear and perfectly frame the large spiral. At the spring and fall equinoxes, a smaller dagger cuts through a smaller spiral to the side. It's a precise and beautiful piece of astronomical engineering. The sun dagger shows that the Chacones had a deep understanding of the sun's annual cycle, known as the solar year. They weren't just guessing, they had identified the key turning points of the year, the solstices and equinoxes, and built a monument to mark them. This knowledge was essential for their survival in a harsh desert environment. It told them when to plant their corn, beans, and squash. It also served as a ritual calendar, a way to schedule their ceremonies and keep their society in sync with the cosmos. But Chaco Canyon is full of even bigger astronomical mysteries. The entire landscape is a celestial map. The so-called greet houses, massive multi-story buildings like Pueblo Bonito, are not randomly placed. Many of them are aligned with solar and lunar cycles. The major buildings are aligned along cardinal directions. The north-south axis of the canyon itself seems to have been a primary line of orientation. Even more impressive is their understanding of the moon. Researcher J. McKim Malville has shown that several key structures in Chaco Canyon align with the 18.6-year lunar standstill cycle, the same complex cycle tracked by the Hopewell culture in Ohio. The chimney at Casa Rinconada, a great kiva or ceremonial chamber, has windows that frame the summer solstice sunrise. Other buildings seem to be positioned to mark the northernmost and southernmost risings of the moon. This is advanced astronomy. To track a cycle that takes almost 19 years to complete requires meticulous record keeping passed down through generations. The Chacoans also built a vast network of roads, some perfectly straight for over 60 miles, connecting the main canyon to outlying communities. Many of these roads seem to have astronomical significance, aligned to cardinal directions or to other celestial events. The whole civilization was organized around a central cosmic blueprint. Then, around 1150 AD, after a prolonged drought, they abandoned the canyon. And they left their great houses and their sun dagger behind, a silent testament to their incredible knowledge. What we still don't know is staggering. How did they achieve such precision in their alignments without modern surveying tools? Was there a class of astronomer priests who held this knowledge as a source of power? And why did they feel compelled to build not just a single observatory, but to engineer their entire society to reflect the order they saw in the sky? Number 11. Could the oldest stories on Earth also be the oldest star maps? For tens of thousands of years, Aboriginal Australians have been telling stories about the dreaming. These are not just myths, they are a complex library of knowledge about law, history, survival, and the cosmos. And it is now becoming clear that these ancient oral traditions contain a staggering amount of accurate astronomical information, making them contenders for the world's oldest astronomers. Unlike many other cultures, they didn't focus on building stone monuments. Their knowledge was encoded in stories, songs, and rock art. They saw the sky as a book of their ancestors. The Milky Way was a river. The dark patches within it were the shapes of animals like the famous emu in the sky. This dark constellation, formed by the dust lanes of our galaxy, was a crucial seasonal calendar. When the emu was rising high in the sky in the evening, it was time to collect emu eggs. When it was low on the horizon, the eggs had hatched. It was a practical living guide. They also had a deep understanding of celestial cycles. Researchers like Dwayne Hamaker have worked closely with Aboriginal elders to document this knowledge. They've found traditions that accurately describe the phases of the moon, the movements of the planets, and the nature of tides. For example, the Yolngu people of Arnhem Land in the Northern Territory have stories that explain how the moon and the tides are linked. Their word for high tide relates to the moon being full or new and directly overhead or underfoot. This is a sophisticated understanding of gravitational forces. Their knowledge of eclipses is particularly impressive. There are oral traditions that describe solar eclipses in detail. They don't just see it as a random event. They understand it as the moon covering the sun. Some traditions warn people not to look at the eclipse, showing an awareness of the danger of staring at the sun. They also seem to have kept records of transient celestial events. There is compelling evidence that certain rock art sites depict impact events, like the fall of a meteorite. A story from the Arunti people of Central Australia talks of a star falling from the sky and creating a giant crater. Geologists have confirmed that the Henbury meteor craters in their traditional lands were formed about 4,700 years ago, well within the time of human occupation. The story is a preserved geological record. Perhaps the most mind-bending discovery relates to variable stars. These are stars that change their brightness over time. The Aboriginal people of the Western Desert have stories about the star Aldebaran, the Eye of the Bull in Taurus, and the Pleiades star cluster. The story involves a starman Niaruna, Orion, chasing the Euryalea sisters, the Pleiades. The story mentions that one of the sisters is shy and hides, which is why only 6 of the 7 sisters are usually visible. What's incredible is that modern astronomers know that one of the stars in the Pleiades, Pleione, is a variable star whose brightness changes, sometimes making it difficult to see. But the stories go further. Some traditions seem to describe the variability of red giant stars like Betelgeuse and Antares. These changes happen over months or years. To notice them, you have to be watching the sky carefully, night after night, generation after generation, and you need a way to pass that information down accurately. Oral tradition was their hard drive. The big questions are profound. Given that Aboriginal culture is the oldest continuous culture on Earth, how far back does this astronomical knowledge go? Are some of these stories 40,000 or 50,000 years old? Could the descriptions of changing coastlines and some dreaming stories be an oral record of the sea level rise at the end of the last ice age, correlated with celestial events? And how much more scientific knowledge is hidden within these ancient stories that we have only just begun to understand? Number 10, how do you navigate the largest ocean on Earth with no instruments? The Pacific Ocean is vast. It covers 1/3 of the planet. For centuries, Europeans believed it was an empty expanse, impossible to cross in small boats. They were wrong. The ancient Polynesians had been crisscrossing it for thousands of years. They settled remote islands separated by thousands of miles of open water, from Hawaii to Easter Island to New Zealand. They did it in double-hulled canoes, and they did it without compasses, without sextants, without maps. Their map was the sky. Their compass was the stars. This is the science of wayfinding. It is one of the most remarkable intellectual achievements in human history. It wasn't just about looking at the North Star. The Polynesians used a complete system, a mental model of the entire ocean. The foundation of this system was the star compass. They didn't think of the cardinal directions north, south, east, and west. Instead, they memorized the rising and setting points of about 150 different stars. As the Earth rotates, stars rise at a specific point on the eastern horizon and set at a specific point on the western horizon. These points do not change. A wayfinder would memorize a compass of 32 points on the horizon, each marked by a rising or setting star. To hold a course, the navigator would keep the canoe pointed toward the rising point of one star, and when that star climbed too high in the sky, they would switch to the next star rising at the same point. The system was passed down orally through generations of master navigators. One of the last to hold this traditional knowledge was Malpiailug from the island of Satawal in Micronesia. In 1976, he agreed to guide the Hokulea, a replica of a traditional Polynesian voyaging canoe, from Hawaii to Tahiti to prove that the ancient voyages were possible. He used no instruments. He navigated by the stars, the sun, the ocean swells, the wind, and the flight of birds. He made the 2,500-mile journey successfully, sparking a renaissance in Polynesian culture and voyaging. The knowledge was incredibly detailed. Wayfinders knew which stars passed directly over specific islands. The star, Arcturus, known as Hokulea in Hawaiian, passes directly over the zenith of Hawaii. If you sailed north until Arcturus was straight above you, you knew you were at the right latitude for Hawaii. Then you just had to sail east or west to find it. They also used the sun, memorizing its rising and setting positions throughout the year. But at night, the stars were their guide. They also read the ocean itself. They could detect the presence of a distant island long before they could see it by observing the patterns of ocean swells. The waves from the open ocean move in long regular lines. When they pass an island, they refract and bend around it. A skilled navigator could feel this change in the motion of the canoe and know that land was near. They watched for cloud formations that tend to gather over islands, or the flight paths of birds that nest on land but feed at sea. It was a holistic science using every piece of available information. So, what do we still not know? How did the first navigators discover these remote islands in the first place? Were these voyages of exploration or accidental drift? How did they manage to transmit such a complex body of knowledge orally without error for thousands of years? And are there subtle navigational techniques they use, perhaps related to ocean color or water temperature, that we have not yet fully understood or documented? Number 9, did Vikings use magic crystals to navigate by the stars? The Vikings were masters of the sea. From the 8th to the 11th centuries, these Norse seafarers sailed from their Scandinavian homelands to raid and trade across Europe, from Russia to North America. They crossed the treacherous North Atlantic, settling Iceland and Greenland, and reaching Newfoundland 500 years before Columbus. They did this in open longships without magnetic compasses, so how did they find their way? Part of the answer is that they were expert coastal navigators, hugging the shorelines whenever possible. But for the open ocean crossings to Iceland and beyond, they needed something more. They used the sun and the stars. At night, they relied on Polaris, the North Star. Its height above the horizon gives a good indication of latitude. By keeping Polaris at a constant height off the side of the ship, they could sail due to east or west. This is a simple but effective technique. But the North Atlantic is famous for its fog and clouds. What did they do when they couldn't see the sun or the stars for days on end? This is where the story gets fascinating and controversial. The Norse sagas mention a mysterious tool, the solarstein or sunstone. For a long time, historians thought this was just a poetic metaphor. But what if it was a real navigational instrument? In 1967, a Danish archaeologist named Thorkild Ramsku proposed that the sunstone was a type of polarizing crystal, like Iceland's spar, a transparent form of calcite, which is common in Scandinavia. These crystals have a property called birefringence. This means they split a beam of light in two. If you look through an Iceland spar crystal at the sky and rotate it, the sky's polarized light will change in brightness. Even on a cloudy day, there is a pattern of polarized light in the sky centered on the sun's hidden position. By rotating the crystal until you find the point of maximum or minimum brightness, you can pinpoint the sun's location with surprising accuracy, even when it's below the horizon. For decades, this was just a theory. But then came the archaeological evidence. In 2013, a piece of Iceland's spar was found on the wreck of the Alderney, an Elizabethan ship that sank in 1592. This showed that such crystals were being carried on board ships, possibly for navigation, long after the invention of the magnetic compass. Recent experiments, like those conducted by researchers at the University of Rennes in France, have shown that the sunstone method can be accurate to within a few degrees. It's a plausible technology. The Vikings likely also used a simple form of sun compass. This might have been a wooden disc with a central pin, a gnomon. By marking the length of the pin's shadow at different times of the day, they could find the north-south line and track the time. But this only works when the sun is out. The sunstone would have been the crucial backup for those cloudy northern skies. Their cosmology was also tied to the sky. They saw the Milky Way as the path to Valhalla. The constellations have their own Norse names. Ursa Major was Carlsvang, or the man's chariot. The sky was both a map and a home for their gods, but many questions remain. Despite the tantalizing clues, no sunstone has ever been definitively found in a Viking archaeological site. Is this because they were rare, or because we haven't recognized them for what they are? How widespread was their use? Was it a secret tool known only to a few master navigators, or was it common knowledge? And did they have other, even more subtle navigational techniques now lost to time that allowed them to conquer the North Atlantic? Number 8, why did a culture of druids build a stone time machine? In the rolling green hills of Ireland and Britain, ancient stone circles stand as silent witnesses to a forgotten age. The most famous is Stonehenge, but these megalithic structures were built by a range of Neolithic and Bronze Age cultures, often associated in popular imagination with the later Celtic Druids. These people were not primitive, they were brilliant astronomers and engineers. They built monuments that were precisely aligned to the movements of the sun and moon, machines for tracking time. Stonehenge is the ultimate example. Built in stages between 3000 BC and 1500 BC, its purpose has been debated for centuries. But its astronomical function is undeniable. The main axis of the monument is aligned to the sunrise on the summer solstice and the sunset on the winter solstice. On the longest day of the year, the sun rises directly over the heel stone as viewed from the center of the circle. It's a breathtaking piece of celestial theater, but the solstice alignment is just the beginning. In the 1960s, a professor of astronomy named Gerald Hawkins used an early computer to analyze Stonehenge's geometry. In his controversial book, Stonehenge Decoded, he argued that the monument was a complex astronomical observatory. He claimed it could be used to predict eclipses of the sun and moon. The 56 Aubrey holes, a ring of pits around the outside of the stone circle, could have been used as a calculator. By moving markers from hole to hole in a specific pattern, the Stonehenge builders could have tracked the complex cycles of the moon, including the 18.6-year nodal cycle that is key to predicting when and where eclipses will occur. While some of Hawkins' specific claims have been disputed, his core idea that Stonehenge was an astronomical device is now widely accepted. Other megalithic sites show similar sophistication. Newgrange in Ireland is a massive passage tomb built around 3200 BC, making it older than Stonehenge and the pyramids of Giza. Above its entrance is a small opening called a roof box. For a few days around the winter solstice, the rising sun shines through this box and down a long passage, illuminating the chamber deep inside the mound. The event lasts for only 17 minutes. It was a stunningly precise way to mark the turning of the year, the rebirth of the sun. It required immense skill to build. In Scotland, the Callanish stones on the Isle of Lewis form a cross shape with a central circle. Archaeoclimatologist Victor Klube and astrophysicist Bill Napier have proposed that these sites were also used to observe comets and meteor showers, which they argue were much more frequent and dramatic in the past. The stones were not just for tracking the regular, predictable cycles, but also for monitoring the chaotic, unpredictable events from the sky. These people had no written language. Their knowledge was passed down through oral tradition and encoded in these giant stone structures. They had a deep understanding of geometry. They likely used ropes and stakes to create perfect circles and lay out complex alignments. The sheer effort involved in quarrying, transporting, and erecting these massive stones, some at Stonehenge, weigh over 40 tons, and were brought from 180 miles away, tells us that this astronomical knowledge was the central organizing principle of their society. The questions that linger are profound. How did they develop such a sophisticated understanding of lunar cycles and eclipse prediction without any written records? Was this knowledge held by a priestly class, the proto-druids, who used it to command power and awe? And do these stone circles encode even more complex astronomical information, perhaps about planets or long-period comets that we have not yet deciphered? Number 7. How did ancient India imagine time on a cosmic scale? While many ancient cultures were focused on the cycles of seasons and years, the astronomers of Vedic India were thinking on a different scale altogether. They were thinking in terms of billions of years. The cosmology that emerged from the Vedas, ancient Hindu scriptures dating back to at least 1500 BC, is one of the most mind-expanding in the ancient world. They conceived of a universe of immense age and infinite cycles of creation and destruction. At the heart of this cosmology is the concept of the yugas, or ages. There are 4 yugas: the Satya Yuga, Treta Yuga, Dvapara Yuga, and Kali Yuga. These ages progress from a golden age of truth to our current dark age of conflict and ignorance. A full cycle of these 4 yugas, a Mahayuga, lasts for 4.32 million years. 1,000 Mahayugas make up a single day of Brahma, which is 4.32 billion years. A night of Brahma is of equal length. During the day, the universe exists. During the night, it is dissolved into a cosmic sleep before being created again. A full life of Brahma lasts for 100 of these cosmic years. This is a timescale that was simply unimaginable to most other ancient cultures. The late astronomer Carl Sagan, in his series Cosmos, noted that Hinduism is the only one of the world's great faiths in which the timescales correspond to those of modern scientific cosmology. The modern estimate for the age of the Earth is about 4.54 billion years, remarkably close to a single day of Brahma. This wasn't just mystical speculation, it was tied to sophisticated mathematical astronomy. The Siddhantas, later astronomical texts from the first few centuries AD, contain detailed mathematical models for predicting the positions of the sun, moon, and planets. Great astronomer mathematicians like Aryabhata, born 476 AD, and Brahmagupta, born 598 AD, made incredible advances. Aryabhata, in his book Aryabhatya, correctly explained that the Earth is a sphere that rotates on its own axis and that the moon and planets shine by reflected sunlight. This was 1,000 years before Copernicus. He also calculated the length of the year as 365.3586 days, which is remarkably close to the modern value. He calculated PIT to 4 decimal places. Brahmagupta was the first to establish rules for working with the number 0. While the concept of 0 existed elsewhere, he formalized its use in mathematical operations like addition and subtraction. This was a crucial step for the development of algebra. These Indian astronomers developed advanced trigonometry, including the sine and cosine functions, which are essential for calculating planetary positions. Their knowledge was so advanced that it was eagerly adopted by Arab and Persian scholars, and from there it eventually made its way to Europe, forming a key part of the foundation for the scientific revolution. Their calendar systems were also incredibly complex, integrating solar, lunar, and planetary cycles. They were aware of the precession of the equinoxes, which they called Ayanamsa. Their understanding of the cosmos was both deeply spiritual and rigorously mathematical. They saw no conflict between the two. The universe was a divine, orderly system that could be understood through the language of numbers. But huge questions remain. What is the origin of the 4.32 billion year cycle? Is it just a mathematical curiosity, or is it based on some long-lost astronomical observation? How did Aryabhata come to the conclusion that the Earth rotates on its axis, a concept that was fiercely resisted in Europe for centuries? And were there even older astronomical traditions in the Indus Valley civilization which predated the Vedas, whose knowledge is now completely lost to us? Number 6. Why did China's emperors need a monopoly on the sky? In ancient China, astronomy was not a science for the people, it was a state secret. The emperor's power was directly linked to the heavens. He was the son of heaven, and his mandate to rule was granted by the celestial realm. If he could accurately predict astronomical events like eclipses, it was a sign that he was in harmony with the cosmos. If he failed, it could be seen as a sign that he had lost the mandate of heaven, which could lead to rebellion and the overthrow of his dynasty. For this reason, astronomy became a jealously guarded imperial science. This led to an unbroken tradition of astronomical observation lasting for over 3,000 years, a record unmatched by any other civilization. From as early as the Shang Dynasty c. 1600 to 1046 BC, Chinese astronomers were recording celestial events on oracle bones. They kept meticulous records of anything unusual in the sky: comets, meteors, new stars, novae and supernovae, and sunspots. These records are an invaluable resource for modern astronomers. For example, Chinese astronomers recorded the appearance of a guest star in the constellation Taurus in the year 1054 AD. They noted that it was so bright it was visible during the day for 23 days. This was the supernova explosion that created the Crab Nebula. Their detailed record of its position and date has allowed modern astronomers to study the remnant of this explosion with certainty. There are dozens of other such records, providing a long-term database of the changing night sky. They also made the earliest confirmed observations of sunspots, which they saw as omens, thousands of years before they were observed with telescopes in Europe. To make these observations, they built elaborate observatories. The Gacheng Astronomical Observatory, built in the 13th century during the Yuan dynasty by the great astronomer Guo Shoujing, is the oldest surviving observatory in China. But it was the culmination of centuries of tradition. Guo Shoujing developed a new calendar, the Shaoxi calendar, which determined the length of the year to be 365.2425 days. This is the exact same value as the Gregorian calendar we use today, but Guo's calculation was made 300 years earlier. It was the most accurate calendar in the world at the time. The Chinese also developed sophisticated astronomical instruments. They invented the equatorial mount for telescopes, a design that allows an instrument to track a star with just one motion. They did this long before telescopes were even invented, using it for instruments like armillary spheres, which are models of the celestial sphere. An armillary sphere is a complex device of nested rings that represent the celestial equator, the ecliptic, and other important circles of the sky. It can be used to measure the coordinates of stars with great precision. The great astronomer Zhang Heng, who lived in the Han Dynasty 206 BC, 220 AD, not only created a detailed star catalog of about 2,500 stars, but also invented the world's first seismoscope to detect earthquakes. He believed that the Earth and the heavens were interconnected. Their view of the cosmos was different from the West. They did not develop a geometric model of the solar system like the Greeks. Instead, they focused on charting the positions of stars and predicting events. Their star maps were among the most advanced in the ancient world. The Dunhuang star chart from the Tang Dynasty around 700 AD is the oldest complete star map preserved on paper. It shows over 1,300 stars with remarkable positional accuracy. The big questions are intriguing. Because astronomy was a state secret, how much unofficial astronomical knowledge existed among the common people that was never written down. Their focus on prediction and record keeping prevent them from developing a physical model of the universe, like a heliocentric theory. And what other guest star events are described in their vast historical records that modern astronomers have not yet identified? Number 5. How did the Inca weave the stars into Assyrian strings? The Inca Empire was the largest in the pre-Columbian Americas. From their capital city of Cusco in the high Andes of Peru, they ruled a vast and diverse territory. To control such an empire, they needed a sophisticated system of organization. They found that system in the sky. For the Inca, the cosmos was not a distant, abstract realm. It was a blueprint for life on Earth. Their entire empire was a reflection of the stars. Cusco was the center of their universe, the navel of the world. The city itself was designed as a cosmic map. It was divided into 4 quarters, representing the 4 quarters of their empire. From the central temple, the Coricancha, or Temple of the Sun, a system of invisible lines called siques radiated out into the landscape. Along these siques were hundreds of sacred shrines, or huacas. As the historian and archaeoastronomer R. Tom Zuidema demonstrated, this Siki system was a giant mnemonic device, a way of encoding the Inca calendar, social structure, and cosmology into the landscape itself. Certain Sikis were aligned with the rising and setting points of the sun at the solstices and equinoxes. Other alignments pointed to the rising of important stars, like the Pleiades. The entire Sacred Valley was a giant astronomical instrument. The Inca paid close attention to the sun. The Inti Raymi, the Festival of the Sun, was their most important ceremony, held on the winter solstice. They built precise solar observatories. At Machu Picchu, the famous Intihuatana stone, or hitching post to the sun, is believed to have been used to track the sun's progress throughout the year. At the winter solstice, the sun appears to set directly behind one of the sacred peaks, as viewed from the stone. They also built pillars on the hills around Cusco that served as horizon markers. By observing where the sun rose and set in relation to these pillars, they could determine the exact day of the year. This was crucial for their agricultural cycle, especially for planting maize at the correct time in their high-altitude environment. But they didn't just watch the bright stars. Like the Aboriginal Australians, the Inca were masters of dark constellation astronomy. They saw shapes in the dark dust lanes of the Milky Way. To them, the Milky Way was a celestial river, Mayu. Within it, they saw a llama, a fox, a toad, and other animals. These dark constellations were just as important as the bright ones. The position of the Ikana, the celestial llama, in the sky told them when it was time for the real llamas to give birth. The Inca had no traditional writing system. Instead, they used the quipu, a complex system of knotted strings. For a long time, it was thought that quipus were just for accounting, for tracking census data and tribute payments. But a growing number of researchers, like Gary Urton of Harvard University, believe that quipus could also encode stories, histories, and astronomical data. The color of the strings, the type of knot, the position of the knot, all of these could have been part of a complex binary code. It's possible that the detailed astronomical observations of the Inca were recorded not in books, but in these bundles of knotted strings. We are only just beginning to crack the code. The questions that remain are vast. Can we ever fully decipher the quipus and unlock the astronomical secrets they might hold? How precisely did the Sikri system work, and what other celestial events did it track? And what was the full extent of their astronomical knowledge before the Spanish conquest in the 1530s destroyed their empire and burned their records? Number 4 were the pyramids of Giza, a map of the stars on Earth. No ancient civilization captures the imagination quite like Egypt. Their pyramids, their pharaohs, their pantheon of gods, it's all shrouded in an aura of mystery and grandeur. But behind the mystique was a civilization built on order, precision, and a deep connection to the sky. For the ancient Egyptians, astronomy was not just a science, it was the key to eternity. Their entire civilization was regulated by the sky. Their calendar was one of the first truly solar calendars in history. They knew the year was about 365 days long, but their most important celestial event was the annual heliacal rising of the star Sirius, which they called Sopdet. This is the first day of the year that Sirius is visible in the eastern sky just before sunrise. In ancient Egypt, this event coincided with the annual flooding of the Nile River, the event that brought fertile silt and made agriculture possible. The rising of Sirius was the herald of this life-giving flood. It was their New Year's Day. The precision of this observation was the foundation of their stable and long-lasting civilization. The pyramids themselves are the most spectacular evidence of their astronomical skill. The Great Pyramid of Giza is an engineering marvel. It is aligned to the 4 cardinal directions with an accuracy of within 1/10 of a degree. This is a level of precision that is difficult to achieve even today. How did they do it? They likely used a method of observing the rising and setting of a star in the northern sky and bisecting the angle between those 2 points to find true north. But the alignments might be even more complex. In the 1980s, an author and engineer named Robert Bauval proposed the Orion correlation theory. He suggested that the layout of the three main pyramids at Giza was a deliberate map of the three stars in Orion's belt. The size of the pyramids corresponds to the brightness of the stars, and their alignment matches the alignment of the stars, including the slight offset of the third pyramid, just as the third star in the belt is slightly offset. Furthermore, Bauval argued that the so-called air shafts in the Great Pyramid were not for ventilation, but were astronomical sightlines. To show that in the era that the pyramids were built around 2500 BC, the southern shaft of the king's chamber pointed directly at Orion's belt, which the Egyptians associated with the god Osiris. The southern shaft of the queen's chamber pointed at Sirius, associated with the goddess Isis. The northern shafts pointed at circumpolar stars, the imperishable ones that never set, which the Egyptians saw as a destination for the pharaoh's soul. The pyramid was a machine for launching the pharaoh's spirit to the stars. This theory is controversial among mainstream Egyptologists, but it highlights the deep celestial focus of Egyptian religion. Their entire conception of the afterlife was astronomical. The pharaoh's soul had to journey through the underworld before being reborn in the sky, becoming one of the eternal stars. The texts found in pyramids, known as the pyramid texts, are full of astronomical references, spells to help the pharaoh navigate the celestial realm. They also had a system of 36 star groups called decans. These were used to tell time at night. Each decan would rise on the horizon at a specific hour of the night, acting as the hand of a celestial clock. They created star charts on the ceilings of tombs, like the one in the tomb of Senenmut, which is one of the oldest detailed astronomical diagrams we have. It stays more than human. It shows the planets, the northern constellations, and the decan. How exactly did they achieve the incredible precision of the Great Pyramid's alignment? Is the Orion correlation theory correct, or is it a coincidence? And did they have a more advanced understanding of the solar system than their religious texts let on, knowledge that was reserved for a select few priests and has since been lost? Number 3, how could a civilization create a calendar more accurate than ours? In the jungles of southern Mexico and Guatemala, the Maya built a civilization that was obsessed with time. They were arguably the most sophisticated astronomers in the ancient Americas and perhaps the entire ancient world. They didn't just measure time, they worshipped it. They developed multiple interlocking calendars that were more complex and more accurate than the calendar used in Europe at the time. The foundation of their system was the 260-day Solkin and the 365-day Hab, which combined to form the 52-year calendar round. But they needed a way to track longer periods of history. For this, they used the long count. This is the calendar that famously ended on December 21st, 2012. Of course, it didn't end, which it was simply the end of a major cycle, a Baktun, much like our calendar rolls over from 1999 to 2000. The long count tracks the number of days from a mythical start date in 3114 BC. It allowed them to record historical events with pinpoint accuracy over vast stretches of time. To maintain such a calendar, you need incredibly accurate astronomical observations. The Maya were masters of this. They built dedicated observatories. The most famous is the Caracol at Chichen Itza. This round building, which looks like a modern observatory, has windows that are aligned to key astronomical events. They frame the northernmost and southernmost setting points of Venus, the sunset on the equinoxes, and other important celestial positions. Their understanding of the planet Venus was extraordinary. Venus was a god of war to them, and its movements dictated when they would go to battle or perform major rituals. They knew that its synodic period, the time it takes to reappear in the same spot in the sky, is about 584 days. They also knew that 5 of these Venus cycles, 5 times 584, 2,920 days, is almost exactly equal to 8 solar years. 8 times 365 ye, 2,920 days. This allowed them to correlate their Venus calendar with their solar calendar. This incredibly detailed knowledge is laid out in the Dresden Codex, one of the few Mayan books to survive the Spanish conquest. The Codex is essentially an astronomical ephemeris, a book of tables that predicts the future positions of Venus with breathtaking accuracy. It also contains tables for predicting solar and lunar eclipses. They understood the complex cycles that govern when eclipses can occur, and they could predict them far in advance. The Maya calculated the length of the solar year with incredible precision. Their estimate was 365.2420 days. The true value is 365.2422 days. For comparison, the Julian calendar used in Europe for over 1,500 years was based on a year of 365.25 days. The Mayan value was more accurate. It's so accurate that it's only off by about 17 seconds a year. To achieve this, they needed to make observations over hundreds of years and have a mathematical system capable of handling the data. They did. Their vigesimal-based 20-number system, which included the concept of zero, was perfectly suited for these large-scale calculations. Their knowledge went beyond the Sun, Moon, and Venus. They tracked Mercury, Mars, Jupiter, and Saturn. They had their own zodiac and constellations, though they are difficult to fully reconstruct. The sky was a living, divine entity, and its movements were the language of the gods. You know, the work of archaeoastronomers like Anthony Avini has been crucial in decoding the astronomical knowledge hidden in Mayan art, architecture, and writing. And yet, so much is unknown. How did they first develop their complex calendrical systems? Were they the inheritors of Olmec knowledge, or did they develop it independently? What other planets or stars did they track with the same precision as Venus? And what other astronomical secrets were contained in the hundreds of Mayan books that were systematically burned by the Spanish in the 16th century? What did we lose in those fires? Number 2, how did ancient Greece give birth to the modern cosmos? The ancient Greeks inherited a wealth of astronomical knowledge from the Babylonians and Egyptians. But they did something new with it. They weren't content to just observe and predict. They wanted to understand. They were the first to try to create a physical, rational model of the universe. And they tried to answer the question, how does it all work? This intellectual leap is the foundation of all modern science. The story starts with early philosophers like Thales of Miletus c. 624 to 546 BC, who is said to have predicted a solar eclipse in 585 BC. But it was Pythagoras and his followers who made the first big conceptual jump. They proposed that the Earth was a sphere and that the movements of the planets could be described with mathematics. They believed the universe was a cosmos, an orderly and harmonious system governed by the laws of geometry and number. Over the next few centuries, Greek thinkers built on this idea. Eudoxus of Cnidus developed a complex model of nested spheres to explain the motion of the planets. Aristotle argued for a geocentric model, with the Earth at the center of the universe, a model that would dominate Western thought for nearly 2,000 years. But not all Greeks agreed. Aristarchus of Samos in the 3rd century BC proposed a radical idea, a heliocentric model, with the sun at the center and the Earth revolving around it. He was thousands of years ahead of his time. He even tried to calculate the relative sizes of the Earth, Moon, and Sun. His methods were ingenious, though his results were inaccurate due to a lack of precise instruments. Perhaps the greatest observational astronomer of antiquity was Hipparchus of Nicaea c. 190 to 120 BC. He created the first comprehensive star catalog, listing over 850 stars and inventing the magnitude system to classify their brightness, a system we still use today. And by comparing his own observations with older Babylonian records, he made a stunning discovery: the precession of the equinoxes. He noticed that the position of the stars had shifted over time relative to the equinox points. He calculated the rate of this slow wobble of the Earth's axis with remarkable accuracy. This was a discovery that required centuries of data and a brilliant analytical mind. Eratosthenes, a librarian at the Great Library of Alexandria, performed a famous experiment to calculate the circumference of the Earth. He knew that on the summer solstice, the sun was directly overhead in the city of Syene as it shone straight down a deep well. On the same day in Alexandria, further north, the sun cast a shadow. By measuring the angle of that shadow and knowing the distance between the two cities, he calculated the Earth's circumference to be about 25,000 miles. He was incredibly close to the true value. The culmination of Greek astronomical knowledge is found in the work of Claudius Ptolemy in the 2nd century AD. His book, the Almagest, is the most important scientific text of the ancient world. It presented a complete mathematical model of the universe. It was a geocentric model, but it was incredibly sophisticated, using complex devices like epicycles and difference to accurately predict the positions of the planets. Ptolemy's model was so successful that it became the undisputed authority on astronomy in Europe for the next 1,400 years, until it was finally overthrown by Copernicus. And then there is the Antikythera mechanism, discovered in a shipwreck off the coast of a Greek island in 1901 This device from the 2nd century BC is an astronomical computer of breathtaking complexity. With its system of over 30 bronze gears, it could predict the positions of the sun, moon, and planets, the phases of the moon, and the timing of eclipses. It shows a level of mechanical and astronomical knowledge that was thought to be impossible for the ancient world. It was 1,000 years ahead of its time. The questions are profound. How could Aristarchus have conceived of a sun-centered universe so long before Copernicus, and why was his idea rejected and largely forgotten? What other technological marvels like the Antikythera mechanism were created and are now lost at the bottom of the sea or melted down for their metal? And how much knowledge was permanently lost with the burning of the Library of Alexandria? So number 1, did all astronomy begin on a Babylonian clay tablet? If you had to pick one civilization that laid the groundwork for all of Western astronomy, it would be the Babylonians. Flourishing in Mesopotamia after the Sumerians, from around 1895 BC until the Persian conquest in 539 BC, they turned stargazing into a true mathematical science. They were not just observers, they were relentless recorders and brilliant calculators. Their legacy is written on thousands of clay tablets, the hard drives of the ancient world. The Babylonians believed in a deterministic universe. What happened in the heavens directly influenced events on Earth. This belief, which we would call astrology, was the driving force behind their astronomy. To predict the future, they needed to be able to predict the movements of the planets. This pushed them to develop a sophisticated mathematical astronomy. They didn't care about physical models like the Greeks. They wanted a system that worked, a set of rules that could predict where a planet would be on any given date. And they succeeded. Their records are staggering in their detail and time span. Some of their astronomical diaries contain continuous day-by-day records of celestial events for over 600 years. This long-term data allowed them to see patterns that no other culture could. They determined the synodic periods of the planets, the time it takes for them to return to the same position relative to the sun, with an accuracy that was not surpassed until the Renaissance. For example, their value for the synodic period of Mars was 779.94 days. The modern value is 779.936 days. They were masters of arithmetic, using their Sumerian inherited sexagesimal-based 60-number system. They developed complex algorithms to calculate the positions of the planets. These were not geometric models, but numerical recipes. A tablet known as Mul.Apin, dating to around 1000 BC, is a compendium of their astronomical knowledge. It contains a star catalog, rules for a lunisolar calendar, and methods for tracking the movements of the sun, moon, and planets. Their most impressive achievement was their theory of the moon. They understood that the moon's speed varies throughout its orbit. They could predict its position with incredible accuracy. They also cracked the code of eclipse prediction. They discovered the Saros cycle, a period of about 18 years, 11 days, and 8 hours, after which the sun, moon, and earth return to approximately the same relative geometry. An eclipse that occurs on a certain date will be followed by a similar eclipse one Saros cycle later. This allowed them to create tables that could predict lunar and solar eclipses with a high degree of confidence. One of the most famous Babylonian astronomical texts is the Venus tablet of Amisaruka. It's a record of the risings and settings of the planet Venus over a period of about 21 years. It's one of our earliest pieces of evidence for systematic long-term planetary observation. The work of scholars like Abraham Sachs and Hermann Hunger in translating these cuneiform tablets has revealed the true genius of Babylonian science. They were the first to apply mathematics to the cosmos. They created the zodiac, they named many of the constellations, they gave us our 60-minute hour and 360-degree circle. The very foundations of modern timekeeping and positional astronomy can be traced back to a priest on top of a ziggurat, making marks on a piece of wet clay. Every astronomer who has ever lived stands on the shoulders of the Babylonians. But even here, at the very beginning, there are deep mysteries. How did they first discover the complex cycles like the Saros? Was it a sudden insight by a single genius, or a slow accumulation of knowledge over centuries? Did they have graphical or geometric methods that they used for their own understanding, but that were not recorded on the tablets? And what would they think if they knew that the mathematical patterns they discovered in the sky were not the whims of gods, but the workings of gravity, a force that holds the entire universe together?